السلام عليكم. اليوم في هذه المحاضرة هنتكلم عن bone. The objectives of this lecture is to identify the structure and function of bone tissue and to explain the characteristics of its components. The second objective is to identify the types of bone and to explain the structural and functional differences between them. The third objective is to explain the process of bone development. The contents of this lecture will be bone cells, the osteoblasts, the osteocytes, osteoclasts, bone matrix, periosteum and endosteum, types of bone, lamellar bone, woven bone, and osteogenesis. The bone is a specialized connective tissue and is composed of two major components, the bone matrix and three types of cells. So it's composed of bone matrix and cells. Let's talk first about these bone cells. There are three major types: the osteoblasts, the osteocytes, and the osteoclasts. We will talk in the following slides about each one of these cells. First, we will start with osteoblasts. The mature osteoblasts are located exclusively at the surfaces of bone matrix. This is the location at the surfaces of bone matrix, the location of the osteoblast. And they function to synthesize and secrete the organic components of bone matrix. هنتكلم في السلايدز الجاية عن ال bone matrix and the components. The osteoblast specifically synthesize and secrete the organic components of bone matrix. And also the position of inorganic materials or components of bone also depends on viable osteoblasts. So these two functions show us the importance of these cells in bone, the osteoblasts. Let's see in this image how the osteoblasts look like. In this diagram, this region is a mesenchymal tissue, and also this is a mesenchymal tissue. This is the bone tissue. In the bone tissue, we'll find the osteoblast found at the surface of the bone matrix. This bone matrix in the middle. Okay, and the osteoblast found at the surface near to the mesenchymal tissue. This is the osteoblast. And the osteocytes are found within inside the bone and surrounded by the bony matrix. The osteoclast also found near the surface of the bone matrix. On the right side, this is an etched and stained section of bone. As we see here, this is a mesenchyme, and all this is a bone. This region, red region, is a bony matrix. Within the bony matrix, we'll find the osteocytes. OC stands for osteocytes, found within lacunae. And on the surface of the bone matrix, we'll find the osteoblasts. Okay, OS is the osteoid. This region is the osteoid. We will talk later about what do we mean by the osteoid. It is a newly formed matrix, bone matrix, called osteoid. And B stands for bone matrix, the bony matrix. This is roughly how the osteoblast looks like. The osteoblasts, active osteoblasts, have a cuboidal to columnar shape, and they have basophilic cytoplasm, yani darkly blue stain cytoplasm, darkly stained cytoplasm. Okay, especially in hematoxylin and eosin stain sections. So the active osteoblasts, they are cuboidal to columnar. The inactive osteoblasts, they are flat and have reduced basophilia. And once the synthesis of bony matrix is stopped or decreased, the osteoblasts become inactive and they flatten, become more flat, and the basophilic or the basophilia will be reduced. Inactive osteoblasts also represent most of the flattened bone lining cells in both the endosteum and periosteum. In the endosteum and periosteum, these are connective tissues found. Periosteum surrounding the bone, endosteum in the inner surface of bone. We'll talk about them later. This diagram again, you see the osteoblasts, they are cuboidal here and columnar here, nearly columnar. فبيجي شكلها some of them are cuboidal, some of them are nearly columnar. They are large, yani taller cells, taller than the inactive cells. When they become inactive, they become flattened like this. These are inactive osteoblasts. Also, we see here the osteoblast OB. These are active osteoblasts found on the surface of the bone matrix. And they synthesize the organic components of the bony matrix and also most of the inorganic material of the bone matrix. The osteoblasts are polarized cells. They have an apical surface and base. The matrix components, bone matrix components, are secreted from the osteoblast at the cell surface in contact with the existing bony matrix, producing the osteoid. The osteoid, which is a newly formed matrix material found between the osteoblast layer and the pre-existing bone surface. You will see in the image here. As we see, this is the osteoblast and this is the bony matrix, and this lighter red region is the osteoid. So the osteoblast, they form the osteoid in the space between in the region between the osteoblast layer and the bony matrix. Okay, the osteoblasts are polarized cells, and the matrix components are synthesized and secreted into the surface of the bony matrix, and this osteoid is a newly formed material, non-calcified yet. لسه ما حصل لها calcification عشان تبقى bony matrix. This is the osteoid. Okay. The osteoblast. In the osteoblast, this process, previous process explained, is called the bone oppositional growth. No growth from the direction from outside, from to inside, from the direction of the osteoblast towards the bony matrix. The bone oppositional growth is completed by subsequent deposition of calcium salts into the newly formed matrix, the osteoid. يعني باختصار, it's completed by calcification of the osteoid. The addition or deposition of calcium salts into the osteoid. We finished the osteoblast. Now we are going to move the second type of cells, which is the osteocytes. And here many osteoblasts are gradually surrounded by the material they secreted and differentiate further as osteocytes enclosed singly within the lacunae. So the osteocytes, each osteocyte is enclosed in single lacunae. Let's see. When the osteoblasts finish the bone formation and they differentiate into osteocytes. And these osteocytes, they are found within lacunae. The lacunae is surrounded by the bony matrix. Osteocytes. Osteocytes, in the transition from osteoblast to osteocyte, the cells extend many long dendritic processes. These dendritic processes or osteocytic processes, they become surrounded by calcifying matrix. These osteocytic processes thus come to occupy the many canaliculi that radiate from each lacunae. Here we have said the dendritic processes or the osteocyte processes, they become surrounded by calcifying matrix. These calcifying matrix result in formation of canaliculi. قنوات صغيرة بتمتد فيها هذه dendritic processes. So the osteocytic processes, they come to occupy the many canaliculi. These canaliculi radiate from where? From each lacunae. Let's see in this image how the osteocytes look like. On the left side, we have transmission electron microscope. Both pictures are taken by electron microscope, different types. On the left side by TEM, or transmission electron microscope, the right side by scanning electron microscope. On the left side, let's see, this is the osteocyte. Okay, and this is the nucleus of the osteocyte. Here, these are cytoplasm, fine rim in the cytoplasm, and the cytoplasm the osteocytes extend cytoplasmic processes that pass into the C. C stands for canaliculi. These are canaliculi. So, surrounded by calcified bony matrix. And in these osteocytic processes, they extend into the canaliculi. So this is lacuna, and the lacuna, this space is called lacuna. Within this lacuna is the osteocyte. The osteocyte extends cytoplasmic processes that enter into the canaliculi. These are the canaliculi which extend from the lacuna. On the right side, this is a scanning electron microscopic picture بتدينا صورة مجسمة كده عن الاوستيوسايتس. دي osteocyte. بنلاحظ إنه الاوستيوسايت found within اللي شايفينها دي لاكونة، فهي it's found within the lacuna, and this is the canaliculi extending from the lacuna. These processes are canaliculi. Inside the canaliculi we'll find the osteocytic processes. The osteocytes also communicate with one another via gap junctions. زي ما شفنا في السلايد اللي فاتت، the osteocytes they communicate with each other via gap junctions. Gap junctions موجودة in the canaliculi، موجودة between the dendritic processes, in the dendritic gap junctions found in the dendritic processes, and also found in the adjacent cells and the osteoblast. The osteocytes, when compared with osteoblast, the flat almond-shaped osteocytes, So the osteocytes are flat almond shaped. They exhibit significantly less, they have less rough endoplasmic reticulum, smaller Golgi complexes, and more condensed nuclear chromatin. Okay, this is in comparison to osteoblast. Less rough endoplasmic reticulum, smaller Golgi complexes, more condensed nuclear chromatin. The osteocytes, these cells, they maintain the bony matrix, and they produce the protein sclerostin and certain cytokines that help regulate bone remodeling. الأوستيوسايتس هي من الخلايا المهمة في البوني ماتريكس. It maintains the bony matrix, produces the sclerostin protein, sclerostin and certain cytokines which help in regulating the bone remodeling. bone remodeling مهم جدا في حالة الفراكشرز والبون ريبير، اللي هو إعادة تشكيل العظم. The death of the osteocytes is يعني once the osteocytes died يحصل طوالي rapid matrix resorption. طوالي بيحصل امتصاص وذوبان وتكسير للماتريكس. Rapid matrix resorption. So their death is followed by rapid matrix resorption. The osteocytes have roles in calcium homeostasis. بتلعب دور كبير في تنظيم مستوى الكالسيوم في الجسم. And they act as sensors for detection of mechanical stresses on bone. وبرضه the osteoclasts are very large. Sorry, we have finished the previous osteocytes. Now we are moving to the third type of cells, which is the osteoclast. And the osteoclasts are very large motile cells with multiple nuclei, and they play a major role in matrix resorption during the bone growth and remodeling. How the osteoclasts look like, as we see here in this section. This osteoclast, OCL, this is the osteoclast. B is the bony matrix, this is the bony matrix. Okay, and OC stands for osteocytes found within Laconi. This is the osteoclast, large motile cell, multiple nuclei with multiple nuclei, multinucleated large cell osteoclast. مهمة جدا في bone resorption during bone growth and remodeling. The osteoclasts in areas of bone undergoing resorption, the osteoclasts lie within cavities in the matrix, known as resorption cavities, also called howe-shaped lacunae. Okay, these are the resorption cavities found in the matrix. It contains the osteoclast. ودي بتكون 200 when the bone is undergoing resorption. في حالة تكسير العضو وذوبانه الأوستيوكلاست بتكون active، بتكون قاعدة لنا في resorption cavities اسمها howe-shaped lacunae. In active osteoclast, the surface against the bone matrix is folded. السطح اللي بيكون مواجه البون ماتريكس بيكون folded into irregular projections، يسموه ruffle border. The ruffle border, which is the site of adhesion to the matrix. Okay, and this region, the region of adhesion, this circumferential adhesion zone, creates a microenvironment between the osteoclast and the matrix in which bone resorption occurs. يعني عندنا osteoclast في السطح بتاع المواجه للبون ماتريكس بتكون في folds اسمها irregular cytoplasmic projections، نسميه رفع البوردر. دي الحتة اللي بيحصل فيها adhesion للماتريكس. طيب ما بين الرفع البوردر ده وبين البوني ماتريكس في سبيس صغيرة فيها micro environment between the osteoclast and the matrix. micro environment دي created by زي ما قلنا circumferential adhesion zone بتاعت الاوستيوكلاست. Let's see in the next diagram. This is the osteoclast and these are the ruffled border or the irregular cytoplasmic projections. And this is bone matrix here. Between the bone matrix and the osteoclast there is this zone. This zone is called circumferential adhesion zone. Okay, between the bone matrix and the ruffled border of the osteoclast is a microenvironment. مساحة بسيطة هي عبارة عن microenvironment بيحصل فيها شنو؟ البون resorption. ال pH of this space is acidic and it's made acidic by pumping the osteoclast. تعمل pumping لprotons, hydrogen ions into this space. So the pH will become very low, acidic, and this acidic environment will result in dissolving the calcium apatite, dissolving the bone matrix. بتذوب الكالسيوم الموجود في البون matrix. And also this acidic environment is suitable for or optimal for the activity of the lysosomal enzymes. The lysosomal hydrolases, they act here in this acidic environment, which is optimal for their activity. The lysosomal enzymes will digest or degrade or hydrolyze the proteins in the bone matrix. So this will result in breakdown of the bone matrix or bone resorption. Now we finished the cells, bone cells. Now we are moving to the bone matrix, and in the bone matrix we have inorganic material and organic material. The inorganic material represents about 50% of the dry weight of bone matrix. 50% inorganic اللي هي عبارة عن شنو؟ أملاح. Calcium hydroxyapatite is the most abundant, but bicarbonate, calcium يعني bicarbonate, citrate, magnesium, potassium and sodium ions are also found, but the most abundant is calcium hydroxyapatite. واللي هو قلنا في السلايد اللي فات هو اللي بيحصل له dissolving by the acidic environment found in the region in the microenvironment between the osteoclast and the bone matrix. Significant quantities of amorphous non-crystalline calcium phosphate are also present. Amorphous calcium phosphate, they are also present. The surface ions of hydroxyapatite crystals are hydrated, and this water or hydrated surface of the hydroxyapatite crystals, this water facilitates the exchange of ions between the bony matrix and the body fluids. The organic matter embedded in the calcified matrix includes type 1 collagen. This is organic matter, type 1 collagen, protoglycan aggregates, and bone-specific multi-adhesive glycoproteins, osteonectin. This osteonectin is multi-adhesive glycoprotein. It is bone-specific, found only in bone, osteonectin. This is the organic matter that found in bone matrix. Type 1 collagen, protoglycan aggregates, and multi-adhesive glycoproteins like osteonectin. There is also calcium-binding glycoprotein, osteocalcin, and the phosphatases enzymes released in matrix vesicles by osteoblasts promote the calcification of the matrix. So the osteocalcin, low calcium binding protein, glycoprotein, and the phosphatases, both of them phosphatases released in matrix vesicles. This and this, they will promote calcification of the matrix. Okay. The association of minerals with collagen fibers during the calcification is responsible for the hardness and resistance of bone tissue. يعني الأملاح اللي احنا ذكرناها لما ترتبط مع الكولاجين فايبرز أثناء الكالسيفيكيشن ده بينتج عنه hardness and resistance of bone tissue، الصلابة والمقاومة بتاعت البون بتنتج من السبب ده. Association of the minerals هي الكالسيوم، hydroxyapatite, carbonate, potassium, magnesium, and all these minerals, they bind to the collagen fibers and result in hardness and resistance of it. Now we have finished the bone matrix. We are moving to talk about the periosteum and endosteum. External and internal surfaces of bone are covered by tissue layers with bone forming cells. يعني هي tissue layers عندها bone، فيها bone forming cells or osteoprogenitor cells يعني called periosteum and endosteum. The external surface covered by periosteum, the internal surface covered by endosteum, and both tissue layers have bone forming cells. The periosteum is organized much like the perichondrium. The outer layer, the periosteum has two layers, outer layer and inner layer. The outer layer is dense connective tissue with small blood vessels, collagen bundles, and fibroblasts. As we see in this section of humerus, section in bone, we'll see the periosteum, the outer layer. It has two layers, fibrous layer and cellular layer. Okay, this is the periosteum. On the inner surface of the bone, here near the bone cavity, we have the endosteum. The periosteum bundles of periosteal collagen fibers, called perforating or Sharpey fibers, penetrate the bone matrix, binding the periosteum to bone. So Sharpey fibers هي عبارة عن شنو؟ periosteal collagen fibers، سموها perforating fibers because they penetrate the bone matrix so it binds the periosteum to bone. هي عبارة عن collagen fibers جاية من البريوستيوم perforate البون matrix, so they bind the periosteum to bone. It's called Sharpey fibers, perforating Sharpey fibers. It's bundles of periosteum collagen fibers that bind periosteum to bone. The inner region of periosteum is more cellular layer. يعني the inner layer of the periosteum is more cellular, containing bone lining cells, osteoblasts, and mesenchymal stem cells called osteoprogenitor cells. So the inner layer of the periosteum is cellular layer. The outer layer is fibrous layer. The inner layer, which is the cellular layer, it contains bone lining cells, osteoblasts, and osteoprogenitor cells. The periosteum with the potential to proliferate and differentiate into osteoblasts. The osteoprogenitor cells found in the inner layer of periosteum play a prominent role in bone growth and in bone repair. So the inner layer of the periosteum زي ما قلنا هي cellular وفيها bone lining cells, osteoblast, osteoprogenitor cells. So the osteoprogenitors, because they have the ability or the potential to proliferate and differentiate into osteoblasts, so they play important role, بيقوموا بمهمة كبيرة في bone growth and bone repair. معناها إن البريوستيوم مهم في البون growth and bone repair fractures. Maintaining periosteum is very important. The principal functions of periosteum are to nourish the osseous tissue and provide a continuous supply of new osteoblasts for oppositional bone growth or repair. Nourish the osseous tissue in few blood vessels and nerves, and also the periosteum provide continuous supply of new osteoblast اللي دي محتاجين لها شنو new osteoblast for oppositional bone growth or repair. Now we have finished the periosteum. We are going to talk about endosteum. The endosteum, it's internally found, very thin, covers small trabeculae of bony matrix that project into the myocarditis. And the endosteum is thinner than the periosteum. The endosteum is thinner than the periosteum and contains many cells, osteoprogenitor cells, osteoblasts, and bone lining cells. It's found on the internally, covering the trabeculae of the bony matrix that project into the myocarditis. So we have finished now the periosteum and endosteum. Now we are moving to talk about the types of bone in the body. Macroscopically, or gross classification of bone can be classified into two types. The first type is compact cortical bone, which represents 80% of the total bone mass. 80% من البون is compact cortical bone. The other type is cancellous trabecular or spongy bone, which constitutes about 20% of the total bone mass. In this image, you see the difference between الcancellous in gross appearance. يعني المظهر الخارجي الكومباكت بون صار كده، cancellous trabecular or spongy bone بيصار بالشكل ده. This is the cancellous or spongy bone, and here is the compact bone, cortical bone. Example of the body for compact and spongy bone. In the long bones, we have the bulbous ends called the epiphyses, and they are composed of a spongy bone surrounded by a thin layer or covered by a thin layer of compact bone, like mainly spongy bone or epiphysis covered by thin layer of compact. The cylindrical part of the long bone, اللي هي بيسموها diaphysis, is almost totally composed of compact bone, with a thin region of spongy bone on the inner surface. So cylindrical part of the long bone بيسموه diaphysis مكون بصورة أساسية من الcompact bone with a thin region of spongy bone on the inner surface near to the bone marrow or the marrow cavity. As we see in this image, this is a long bone. Okay, humerus. This is a longitudinal section. احنا هسه شايفين من جوا البون شكله كيف. الأطراف دي هنا دي بيسموها epiphyses، والepiphyses فيها زي ما شايفين هنا spongy bone, trabecular bone, covered by only thin layer of compact bone. And also here, the distal epiphysis, also we have spongy bone. Okay, in the middle, this is the shaft. الجزء الطويل shaft بيسموها diaphysis. And in the diaphysis we have mainly compact bone, cortical bone as we see here. من برا compact bone، من جوا بتكون في very thin layer of spongy bone near the medullary cavity. ده medullary cavity بيكون فيه bone marrow. Okay, so the compact bone المكون الرئيسي بتاع الدايفيسيس هو الcompact bone، والمكون الرئيسي للإبيفيسيس هو spongy bone. Microscopic examination of bone tissue shows two types of organizations: lamellar bone, which is the mature bone found in adults, and woven bone or immature bone, usually found in fetus. We will start with the lamellar bone. Most bone in adults, compact or cancellous, is lamellar bone. Lamellar bone and is characterized by multiple layers or lamellae of calcified matrix. There is what's called osteon or Haversian system. The osteon or Haversian system refers to the complex of concentric lamellae surrounding a central canal that contains blood vessels, nerves, loose connective tissue, and endosteum. Between the successive lamellae are lacunae. ما بين الconcentric lamellae في lacunae, each lacunae with one osteocyte interconnected by canaliculi. This lacunae interconnected by canaliculi containing the cell's dendritic processes. So let's see how it looks like in this diagram. This is bone, okay, section in bone taken here, and in transverse section we will see the osteon, which is composed of concentric lamellae that surrounds the central canal, and the central canal contains blood vessels, vein, artery, and nerve. And it also contains the endosteum and osteoprogenitor cells, and the endosteum, which contains osteoprogenitor cells, osteoblast. Between the lamellae, we have the lacunae, which contains the osteocytes. These الخلايا دي almond shape، هي شكلها elongated. دي الأوستيوسايتس. الأوستيوسايتس بتطلع منها dendritic processes بتمر داخل canaliculi. So the lacuna, each lacuna contains osteocyte, and the lacunae connected by canaliculi. Canaliculi contains dendritic processes of the osteocytes. So this is the osteon in this diagrammatic picture, and this is a real picture of compact bone, lamellar bone. As we see the same organization here, we have the central canal, CC central canal, and these are the concentric lamellae. L stands for lamellae, concentric lamellae. And these dark regions are what? Osteocytes. As we see here. These are the osteocytes inside lacunae. And these dark processes, lines, are the canaliculi. C stands for canaliculi. Okay. Processes of adjacent cells are in contact via gap junctions. And the dendritic process of this osteocyte and the other one, they are in contact via gap junctions. ذكرناها قبل كده في الاوستيوسايتس اللي اتكلمنا عنها، إنه they contact via gap junctions, and all cells of an osteon or Haversian system receive nutrients and oxygen from the microvasculature in the central canal. The outer boundary of each osteon is a more collagen-rich layer called the cement line. In the outer boundary of each osteon or Haversian system, there is cement line. This is a more collagen-rich layer. It's called cement line. Each osteon or Haversian system is a long, sometimes bifurcated, cylinder, generally parallel to the long axis of the diaphysis, هي shaft of the long bones. فبتكون أي osteon or Haversian system بيكون عبارة عن cylinder. Sometimes بتكون bifurcated. المهم السلندر دي بتكون parallel to the long axis of the diaphysis or the long bone. It consists of what? Of a central canal. Each Haversian system or osteon consists of a central canal surrounded by 4 to 10 concentric lamellae. The central canals communicate with the bone marrow cavity and the periosteum, and with one another through transverse perforating canals. Transverse perforating canals are called Volkmann canals. So the central canal communicates with the bone marrow cavity, and the periosteum, and also with one another through the Volkmann canals, which are perforating canals transversely located. As we see in this image, this is a section in humerus bone. As we see This is the osteon, and this is the osteon, and this is osteon. Osteon or Haversian system. Haversian system. Haversian system. Haversian system. Haversian system. هنا قاطعينه longitudinally. Each Haversian system has a central canal ومن برا في cement line the outer side. طيب لو لاحظنا في longitudinal section في connection في canal ما بين الأوستيون ده and this osteon والأوستيون الجنب. في canal ما بين البون مارو كافيتي والسنترال كانال بتاعت الأوستيون. برضو السنترال كانال بتاع الأوستيون ده مع periosteum. There is a canal. These transverse canals are called perforating canals or Volkmann's canal. Okay, they connect central canal of the osteon with the bone marrow cavity and with each other and with the periosteum. Bone marrow cavity connect the central canal with the bone marrow cavity and also central canal with the periosteum and the central canals with each other. They are connected by perforating canals or Volkmann's canals. The scattered among the intact osteons are numerous irregularly shaped groups of parallel lamellae called interstitial lamellae. تمام between الأوستيونز و between الهافيرشن systems في scattered lamellae بيناتهم بين الهافيرشن systems اسمه interstitial lamellae. These structures are lamellae. دي عبارة عن شنو أصلا interstitial lamellae؟ عبارة عن lamellae فضلت بعد ما حصل destruction للأوستيونز أو الهافيرشن systems by the osteoclast during growth and remodeling of bone. Okay, they are lamellae remaining from osteons that are partially destroyed. Partially حصل لها partial destruction by osteoclasts during growth and remodeling of bone. دي نفس الإيميج اللي قبل كده هنا اللي هي عشان نوريكم interstitial lamellae. زي ما شايفين these are parallel lamellae between the osteons. عشان كده سموها interstitial from its name. ظاهر إنها بتكون in between. This osteon and this osteon and this osteon and this osteon there is lamellae here called interstitial lamellae اللي هي دي بتفضل بعد ما يحصل destruction لواحد من partial destruction لواحد من الأوستيونز أثناء البون remodeling أو bone growth. In compact bone, the lamellae also exhibit typical organization consisting of multiple. في نوع تاني من اللاميلي اسمها external circumferential lamellae دي ببرة خالص and also often some inner circumferential lamellae دي من جوا. نشوفها. The inner circumferential lamellae موجودة وين؟ They are located around the marrow cavity. تكون قاعدة in the inner side around the marrow cavity. وال external circumferential lamellae are located immediately beneath the periosteum. تحت البريوستيوم. شوفها في الإيميج هنا. شايفين اللاميلي دي اسمها external circumferential lamellae just beneath the periosteum. بتكون محاوطة البون كله all around. And on the inner side من جوا عندنا ال internal circumferential lamellae ودي برضها بتكون all around on the inner surface and they are found around the marrow cavity. Here is the site of the marrow cavity where this trabecular bone or spongy bone is found. يبقى عندنا external circumferential lamellae, internal circumferential lamellae, interstitial lamellae, concentric lamellae in the Haversian or the osteon system, the Haversian system, the osteon. So we have finished the lamellar bone, which is the mature bone, and how it is organized. Now we're moving to talk about the woven bone. The woven bone is non-lamellar, ما فيه lamellae, characterized by random disposition of type 1 collagen fibers بصورة عشوائية, and is the first bone tissue to appear in embryonic development and in fracture repair. Okay, so it's immature bone, ما فيه lamellae, مكون من تجمع عشوائي لتايب 1 collagen fibers, وهو أول ما يظهر in the embryonic development and also in fracture repair. وزول adult حصل له fracture in one bone, أول بون متكون هو woven bone, بعد ذاك يحصل له يتحول لماتيور lamellar bone later in repair. Woven bone is usually temporary, مؤقت, and then is replaced in adults by lamellar bone. Woven bone has irregular interwoven array of collagen fibers and a lower mineral content. فيه توزيع عشوائي من الكولاجين فايبرز, محتوى أقل الأملاح المينرالز أقل من lamellar bone, and also it has a higher proportion of osteocytes than mature lamellar bone. يعني هو فيه خلايا أكتر وألياف عشوائية موزعة بصورة عشوائية, محتوى مينرال من الأملاح بسيط. Because of that, these features ذكرناهم ديل, they reflect the fact that woven bone forms more quickly, يتكون بسرعة, but it has less strength than lamellar bone, أقل متانة, أقل قوة من lamellar bone. Okay, so we have finished the two types, microscopic types of bones, the lamellar bone and woven bone, lamellar mature bone and woven immature bone. Then we are going to talk about bone development or osteogenesis, how it occurs briefly. Bone development or osteogenesis occurs by one of two processes: either intramembranous ossification, and in which the osteoblast differentiate directly from mesenchyme and begin secreting the osteoid. Osteoblast differentiate from mesenchyme, تمام, تبدأ طوالي تطلع الأوستيويد اللي هو non-calcified matrix, early newly formed non-calcified matrix to osteoid. The second type of process is on endochondral ossification. من اسمها لازم يكون في pre-existing hyaline cartilage. ال pre-existing hyaline cartilage بيحصل له erosion و invasion by osteoblast. Then these osteoblasts begin the osteoid production. Okay, and in both processes the bone tissue that appears first, سواء كان في الانترامembranous ولا endochondral, the first bone tissue that appears is woven bone, which is soon replaced by stronger lamellar bone. During the growth of all bones, areas of woven bone, areas of bone resorption, areas of lamellar bone, all exist contiguous to one another. يكونوا كلهم يعني موجودين جنب بعض. ده في حالة يكون البون is growing during the growth of bone. Of the areas of woven bone, areas of bone resorption, and areas of lamellar bone all exist contiguous to one another. So we have reached to the end of our lecture, and we have talked about the bone cells, the osteoblasts and osteocytes, the osteoclast and the function of each one, and their importance in bone growth, remodeling, and resorption. Also, we have talked about the lining, the tissues, periosteum and endosteum. Periosteum that covers the bone from outside, the endosteum that lines the bone from inside on the inner surface. And also we have talked about the types of bone, the composition of bone matrix, the organic material and the non-organic material of the bone matrix. And also we have talked about the types of bone in gross examination and in microscopic examination. In gross examination, compact cortical bone and cancellous bone, and in microscopic examination lamellar mature bone and woven immature bone. برضو تكلمنا بصورة مختصرة عن الأوستيوجينيسيس وكيف بيحصل الأوسيفيكيشن either intramembranous or endochondral ossification، وإنه أول بون بيتكون هو الووفن بون، بعدها بيتحول للاميلر بون. And thank you. Good luck.